Have you ever wanted to create like a silent, beautiful explosion right on your dinner plate? Well, today we're going to dive into a super captivating experiment you can do with just a few simple things you've probably got in your kitchen right now. And it really is a puzzle, right? I mean, you take some milk, a bit of food coloring, and just one drop of dish soap. On their own, they're boring. But you put them together, suddenly you get this incredible swirling vortex of color. So the big question is, why? What's the invisible force making all this happen? All right, so before we get into all the nitty-gritty science, let's just take a second to appreciate the effect itself. First up, we're just going to look at what exactly is going on during this little miniature fireworks show. Seriously, just picture this. You've got this totally calm surface of milk, and you dot it with a few drops of color. Then, just one single touch of soap, and boom. Instantly, the colors just burst outward, racing away from the center, swirling and mixing into these incredible patterns. It's this silent, kind of chaotic, but absolutely beautiful dance of chemistry. Okay, so to really get what's happening here, we need to introduce our key players. There are only three of them, but believe me, each one has a super specific and crucial role to play. So first up, we've got whole milk. Think of this as our stage. It's where all the action is going to unfold. Then you've got the food coloring. Now, this one's interesting. It's not actually an active participant. It's more like our messenger, making the invisible action totally visible to us. And finally, the real star of the show, the dish soap. This is the catalyst that just kicks everything into high gear. The real secret to this whole explosion, it all comes down to that one little drop of soap. It's not just for cleaning, you see. It's actually a really powerful chemical agent, and it's designed to cause some serious disruption on a molecular level. I mean, that's its entire job, right? Whether it's on a greasy pan or in a plate of milk, that's what it does. Soap molecules are literally engineered to hunt down and break up fats and proteins. And guess what? Our milk is packed with both, just floating around in the water, pretty much waiting for something to come along and shake things up. And this comparison, wow, it shows the dramatic difference perfectly. So before the soap gets there, the milk has what we call high surface tension. You can almost imagine all the molecules are holding hands, creating this tight, calm surface. But the second that soap hits, it's like a wrecking ball. It just shatters those bonds, the surface tension completely collapses, and everything gets sent flying. So the really crucial scientific idea here is something called surface tension. The easiest way to think about it is like a delicate, invisible film on the surface of the milk. Now, soap is what's known as a surfactant, which literally means surface active agent. Its whole purpose in life is to reduce that tension, and by breaking it, it unleashes all that wild, chaotic movement we're seeing. This chart right here, it perfectly illustrates why the kind of milk you use matters so much. So you've got whole milk, right? It's packed with fat, and it sets off this huge, super energetic reaction. Just look at that high-intensity bar. Now, compare that to skim milk, which has very little fat, and yeah, the reaction is way, way weaker. It's simple. More fat literally means more fuel for the fun. So we've got this invisible molecular battle raging, but how does that turn into the beautiful bursts of color that we actually see? Well, let's talk about our little messenger again. And this is a really important point to get. The food coloring itself, it's chemically neutral in this whole experiment. It's not reacting with the soap, it's not reacting with the milk. It's just sitting there on the surface. And when the milk molecules start getting shoved around by the soap, the coloring just gets carried along for the ride, basically tracing all the currents for us to see. There's a line from the source material that just sums this up perfectly. It says, "The colors are just along for the wild ride." And that's exactly it. You've got the soap and the fat locked in this epic molecular battle, and the colors, they're just being swept up in the chaos, showing us exactly where the action is. But this is so much more than just a cool party trick. The principle we're seeing here, surface tension, it's actually a fundamental force of physics that's happening all around us, every single day. And here is the direct connection to your own life. That colorful chaos happening on the plate, it's the exact same science that helps you clean a greasy pan. The soap isn't just magically making grease disappear. It's doing precisely what we saw it do in the milk. It's attacking those fat molecules, breaking them up, and letting the water just wash them away. This whole experiment is basically a beautiful visualization of how your dishes get cleaned. And once you know what to look for, you start seeing this principle everywhere.
It's what allows those little water strider insects to literally walk on water. It's why raindrops form into those perfect little beads on a leaf. It's even the reason you can fill a glass of water just a little bit past the brim without it spilling over. Surface tension is this constant, invisible force that's always shaping our world.
So, maybe the next time you see some simple, everyday thing happening, it's worth asking yourself, what's really going on beneath the surface here? What kind of unseen forces are at play? Because as we've just seen, sometimes the most spectacular science is happening right there on your plate.